Hi, my name is Mohammed Yahya Al-Bahaisi and my student ID is 1102068. Today I'm going to be talking about my COE 101 Introductory to AI project, and my project is basically about OS icon image classifier. The goal is to train an AI model to recognize and classify operating system icons such as Windows 11, Mac OS, and Linux. Those three types we're going to be talking about today using Google's Teachable Machine platform. So let's talk about Google's Teachable Machine. It's actually a tool used by Google. It lets you train a machine learning model without any coding. You simply gather your data, upload it into classes, click train model, and then test it. That's it. Under the hood, it uses a neural network called MobileNet V2, which is a lightweight neural network that was pre-trained on over 1 million images. So people basically post images to this platform, and then the model gets trained, and it knows how to answer and give results. This technique is called transfer learning. Instead of training from scratch, the model already knows how to detect edges, shapes, and textures, and we just teach it the new specific task, and that's it. The classification problem I chose is image classification from the computer engineering track. I classified 3 types of operating system icons, which are, as I mentioned before, Windows 11 and Mac OS and Linux. Each OS has a very distinct visual design. Windows 11 uses a flat blue minimalist style, but Mac OS uses a glossy 3-dimensional look with vibrant colors. On the other hand, Linux uses the GNOME design with orange and dark tones. These visual differences make this a great problem for an image classifier. Real-world uses include automated UI testing, software cataloging, and building tools that detect the host operating system visually. Now I'm going to talk about the data collection. I collected 90 images in total. 30 per class. All images are original, manually collected icons from each operating system. No online data sets were used. Every image was resized to exactly 512 by 512 pixels using the bulk resize photo tool. As required by the protocol, I ensured data variation by including many different types of icons per OS. App icons, system icons, folder icons, and utility icons. So the model learns the overall design language rather than memorizing specific icons only. The 3 classes are perfectly balanced at 30 images each, which prevents the model from being biased towards any one class. We have 3 classes which are, as I mentioned, Windows, Mac OS, Linux. Every class has 30 images, so it's basically equal. The AI model. The model behind Teachable Machine is MobileNet V2, as I mentioned. It uses depth-wise separable convolutions, which makes it much faster and lighter than a standard CNN, while maintaining strong accuracy. It also uses an inverted residual structure with linear bottlenecks. I trained the model using the default hyperparameters, 50 epochs, a batch size of 16, and a learning rate of 0.001 training. The training completed in approximately 35 seconds, which is remarkably fast and is a direct result of transfer learning. The model didn't need to learn basic image features from scratch. It's like a muscle memory thing. Testing method. For testing, I used the test set method with 70-30 split. That means 63 images were used for training and 27 images were held out for testing. 9 per class, so 9 per Windows, 9 per Mac OS, and 9 per Linux. I also performed a binary classification experiment where I simplified the problem to Windows versus not Windows using 12 test images, which actually you can see them right here. We got 12 images and as well the results. The AI got like 100% score. And for the multi-classifier, I posted them over here. As you can see, it got a 96.30%. Using 12 test images for the binary, for the multi-class classifier, I reported accuracy, a confusion matrix, and training time for the binary. For the binary classifier, I report accuracy, precision, recall, specificity, false positive rate, and ROC and PRC curves, which I'll show you at the end. Results. My multi-class classifier achieved an accuracy of 96.3%, getting 26 out of 27 test images correct. The only misclassification was one macOS icon that was predicted as Linux. This is understandable because both macOS and Linux can have similar folder-style icons. The confusion matrix shows that Windows was classified perfectly 9 out of 9. macOS 8 out of 9 and Linux 9 out of 9. For the binary classifier, the model achieved 100% accuracy. Every Windows icon was correctly identified as Windows, and every not Windows icon was correctly rejected. Precision, recall, and specificity were all 100%. And the false positive rate was 0%. This makes sense because even the macOS image that was misclassified as Linux in the multi-class experiment is still correctly classified as not Windows in the binary experiment. Now we're going to talk about the analysis. Comparing the two classifiers, the multi-class classifier is more informative but slightly harder. It achieved 96.3%. The binary classifier is simpler and achieved 100%. Because the decision boundary is less complex, the main advantage of this model is its speed and accessibility. The main limitation is that it was trained on only 90 images, so it may struggle with edge cases like generic cross-platform icons that look similar across all three operating systems. Right now I'm gonna open Teachable Machine and I'm gonna show you a demo of how we actually test the icons. Now we're gonna upload one Windows image and we're gonna see which class we're gonna get. Class 1 is Windows, class 2 is Mac OS, class 3 is Linux. As we can see, we put this picture in the model and it gave us 100% class 1, which is 100% Windows. And let's try it for another class, for example the Mac OS. I'll upload a picture right now and we'll see how the test results go. I'll upload this one. We got 95% class 2, which is Mac OS. And right now we're gonna upload a Linux image just to make sure. Okay, this time it predicted wrong because the AI model needs to be trained several times. We'll try another picture. It gave us 100% class 3, which is actually Linux. So this project demonstrated actually how transfer learning with MobileNet V2 can achieve over 96% accuracy on a real-world image classification task with only 90 images and under a minute of training time. If I were to repeat this project, I would collect more images actually, if I'm being honest, and include icons from older OS versions and experiment with higher epoch counts to push accuracy even further. Thank you.